Hey friends, here we are in chapter 6 and we're looking at section 6.5. We're going to be talking about solving open sentences involving absolute values. So here we're going to start off with the idea of absolute value. Remember, absolute value is a number's distance from zero, right? And so when we talk about absolute value, ultimately we're talking about an overall positive number, right? So one thing that students sometimes do is they say, oh, nine, I'm not nine, a minus four, absolute value, we're going to make that positive. No, no, no. What this says is whatever's inside, once I do the thing, once I do a minus four, whatever answer that is, it has to be positive. So before we even get started with this problem, I'm just going to ask you to think about this. If I had the absolute value of x is equal to 7, you know that x could be either of two things. X is either a positive 7 or a negative 7, right? You know this. So I want you to keep this in the back of your mind when we're doing any absolute value equations, okay? So this is just a thought bubble and I'm going to make it small so it's not taking up too much space. This is not the problem, guys. This is just what you're thinking. So if this is the case, if this is in the back of your mind, you know that whatever the thingamabobster, and I'm going to call it a goofy name, whatever this thing is within the absolute value, it has to either equal the positive version of this number out here or the negative version. Just like here, right? Because if a minus 4 ended up being negative 3, the absolute value of negative 3 is positive 3. If a minus 4 ended up being 3, the absolute value of 3 is 3. So either way, a minus 4 has to be either 3 or negative 3. So what that does is that creates two equations that we can solve to determine possible values for a. So you have to do this. When you have an absolute value equation, you must consider the possibilities. And to do that, you would set up two separate equations because you're going to get two separate answers oftentimes. So I'm going to solve for a by adding 4 to both sides. And we see that a is either equal to 7, or when I add 4 to both sides in this other equation, I get that a is equal to positive 1. So these are the two answers that I get here. Imagine putting 1 in here. 1 minus 4 is negative 3. The absolute value of negative 3 is positive 3. Boom. Let's try 7. 7 minus 4 is 3. The absolute value of 3 is 3. Boom. So I've got two different answers that work. And this is always going to be the case when we have absolute value equations. Let's check to see what happens when we have absolute value inequalities. So write an equation involving absolute value for the graph. Okay, so we're not doing inequalities yet. We're still thinking about equations. So remember, absolute value refers to distance. In this case, these are a little tricky, but just check out what I'm doing. What you'll do is when you get two different answers, two different numbers that you're supposed to have as the solution for an absolute value equation, what you do is you need to figure out what are you actually finding the distance of. You're finding the distance from, in this case, I know this is weird, you're finding the distance from 6. So you're looking for a number whose difference from 6 or distance from 6 is 3. Does that kind of make sense? Like peep game, right? So what is nine's distance? Nine's distance from 6? It's 3. What is three's distance from 6? It's 3. So what we'll say is we'll write this as x minus 6. The difference between some number and 6 has to equal 3. Does that make sense? You see how we did that? So I'm just now, this is all you really have to do, but I'm going to go through what we just did last time. So you remember last time we had that thought bubble where we're like, oh, whatever this is in here either has to be the positive version of the answer or the negative version of the answer, right? So I get x minus 6 is either equal to 3 or x minus 6 is equal to negative 3. And now I'm going to solve this. So I'm going to isolate x. Let's do this first part of the equation, or this first equation. X is equal to 9. Yeah. And I'm going to do the same thing over here. Adding 6 to both sides. Swoop delicious. X is equal to 6 plus a negative 3 is a positive 3. So I get the two answers, and you see the representation here. So let's go back to what we did. When you see a number line and you're asked to determine what and you've got 2 points and you're asked to determine what the absolute value equation is, you need to think about the number in the middle and the fact that both of those values have a certain distance, have the same distance from the number in the middle. When we talk about distance, we're talking about difference. So x, whatever number this is, minus 6, the distance from 6, the absolute value is 3. And then we proceed and we can solve to show that that represents the same thing. I know that was a lot of talking, but I hope that made sense, seriously. Okay, so now we get into the absolute value inequalities, which takes on kind of a different vibe. So I have kind of a shortcut method to solve these types of problems. And I tell students this. I say, okay, you take t plus 5 and you're going to put this symbol on both sides, and you'll put 9 and negative 9. And then you're going to solve it like a compound inequality. And what I'll do is I'm going to put this to the side for a second and kind of justify my little trick that I did there. So let's say I had absolute value of x is less than, let's say, 1. All right, and this is going to be a thought bubble. So this is not the problem that we are working on. This is just a concept I want you to have in your mind. So if the absolute value of x is less than 1, I'm thinking about the number line and I'm thinking, what are all the possible values that x could be? So I know that absolute value of x is less than 1. So if this is 0 and this is 1 and this is negative 1, right? I'm thinking that the answers that I want are all going to be between negative 1 and 1. All of these are kind of legit, right? All of these can work, because as soon as I get out of that boundary, what I find is that the number is too big when I take the absolute value of it. So in a sense, x is somewhere between 1 and negative 1. So when I have an absolute value that is less than the absolute value of some expression that's less than a number, a positive number, then I know that it is in a sense bounded like this. So that's why when I see this, I literally take this symbol, I write it on both sides, I take the absolute value sign off, and I put a negative 9 here because of this thought process. And so now I'm going to solve this like I would any old compound inequality. Got to isolate the t, so I'm going to get rid of the 5 on all of the sides. Negative 9 plus a negative 5 is going to be a negative 14, less than t, less than 4. And so this is my answer. Graph the solution, no problem. I know that I'm dealing with negative 14 and a positive 4. T cannot equal either of those, and I'm going to shade in between because all of these are possible answers. And now we're looking at a different situation, but the idea is going to be kind of the same. So here's what I'm going to do. I want to give us another thought bubble. If I have x, the absolute value of some value x is going to be greater than a number, let's say 2. Again, this is an analogous relationship, but it is not the same relationship. So I'm going to put it in a thought bubble context and just say your brain should be thinking about this. What values can I say that x could be? And so x has to be, the absolute value of x has to be greater than 2. So it can't be negative 2 or 2. It can't be anything in between. It's actually going to be all the stuff out here. You know, when we have these types of problems, we get an or situation. So we know that this says that x is either greater than 2 or x is less than negative 2. So when you see this, when the absolute value is greater than the number, I want you to know you're going to have a situation like this. How does it translate? I'll show you. So 2x plus 8 is either greater than 6 or 2x plus 8 is less than or equal to negative 6. You see that? You see the analogous situation? And now we're going to solve. And this is always the case, guys. Like you can take this to the bank. This is always going to work. But you just have to remember the relationship. So then we get 2x is greater than 6 plus a negative 8 is a negative 2. X is greater than, divide both sides by 2. Since that's positive, no flipping of the sign, negative 1. So x is greater than negative 1, or I'm going to solve this guy. Subtract 8 on both sides. I get that 2x is less than or equal to negative 14. I'm going to divide both sides by 2, and x is less than or equal to negative 7. So x is either greater than negative 1 or x is less than or, and I think this should have been equal to, my bad. I lost it. Don't be mad. X is either greater than or equal to negative 1 or x is less than or equal to negative 7. So I'm going to graph it. Let's turn this around a little bit. It looks a little bit wonky. Let's see. Maybe I should just erase it. Yeah, just erase it and do it over again. Sorry, people. Wasting your time. Deepest apologies. All right. I'm getting there, people. Okay. So that's nice. So I have a negative 7 here and a negative 1 here as they would appear on the number line. And then I'm going to have solid dots on both of them. And I'll say that x is less than or equal to that, negative 7, or x is greater than or equal to negative 1. So we get a union, right? Union of two separate things. All right, my good friends. So here is the little memory device that you should use. So when you have the absolute value of something that's equal to a number, then you need to know that that thing could equal the negative or positive version of the number. Check. When you have the absolute value of something is less than a number, then you need to know that, and I write it a little bit differently, you need to know that you've got this situation here. X is less than n, and at the same time, x is greater than negative n. That's exactly what's being said here. When you have the absolute value of some number being greater than n, that's when you're going to get an or situation where you literally can write exactly what you see here without the absolute value. So you just write x is greater than n, and then you flip the sign and you change the sign. You flip the sign over and you say, well, or x is less than negative n. And you can totally memorize this. I had another way that I taught this in the past. If you find that that is really confusing, you're like, I cannot figure this out, I have another way that might help you to remember, but I won't trip you up with that unless you tell me you want it. So with that in mind, my good friends, we have come to the end of yet another delightful yet enjoyable lesson. And so let me know if you have any questions, concerns, comments, and I look forward to talking to you soon. Take care, guys.